Hello, here I will go over exam VWO 2021 Tijdvak 3, period 3, and I already worked out the answers to speed up the video a little bit. The first question is about triangle ABC with some given sides and a point M on the side of one of the sides of the triangle, and with a given length from point A. So the situation is drawn here, and you can see there is a small triangle here with 3 angles with all the sides given, and there is a larger triangle with also the 3 angles given here, and to solve this you have to apply the cosine rule, realizing that this angle here at B is shared by both triangles. And given that from the small triangle, using the cosine rule, you can actually determine the angle B, and given that 2 sides of the large triangle are known, namely 12 here and 4 here, you can actually find the length of this unknown side AB here. And the cosine rule is part of the mandatory skills. I can go over that in another video, but here in the document examenprogramma, under so-called geometry skills, they actually particularly mention here that the sine and cosine rules, you have to be able to use these to calculate the length of segments or the angles of the triangles in a triangle, of the angles in a triangle. Okay, so first step is, what is this angle B here? Well, the cosine rule will tell you that the length of the opposite line segment of the triangle squared, so 5 squared, is the 4 squared plus 6 squared, the adjacent segments belonging to the angle, and then minus 2 times also these 2 lengths here, times the cosine of the angle. That's this equation. And from this you need to do some simple manipulation. Then you find that the cosine of B is 0.56 something. And since you know this, we can now apply the same cosine rule for the larger triangle. And again you have the angle B and the opposite segment X here. The same, and now you have to apply it, but with the shared segment of length 4 here and the complete segment length of 12. And then you'll find that x squared is 160 minus 96 times cosine B. I have the cosine B substituted and do the calculation, then in 1 decimal, so that's 10.3. Actually, this is the only question I've seen from 2021 and 2022 where this was asked, so that's interesting. Okay, next question. This is about a function that looks like a spookje. which is coast. Looks like a coast. So there's given a domain here. We have a function f and g given here, and then they state that the derivative of f is given here, and you have to prove that. Well, one basic skill is knowing how to calculate the derivative of a product. You can see this is a sine times a cosine, and that's given here. That should be known. So just apply it to take the derivative of sine, you get a cosine. Derivative of cosine 2x, you get a sine 2x, but with the negative sign, plus the chain rule will give you an extra factor 2. And then you apply, you can see the answer has to be something with only x as argument. So what first you want to do is get rid of the 2x, and there you use the equations that are given on an earlier page of the exam. So these are the ones you don't need to remember. In contrast to the cosine rule, by the way, from the previous question, which is something you have to remember. Then, yeah, just try to substitute these equations, and then you can already see that it's going well here, because we have a sine square and a cosine square. You write the sine squared x as a 1 minus cosine squared x. So that's the second trigonometry equation you have to use. Just put all the like terms together, and then you easily find what they're asking. Then they say there's a vertical line, x is p here, which intersects f in A and g in B. Alright. And then they say they have a look at the tangent of f in A and the tangent of g in B, which are drawn here. And then here they particularly give a situation where these two tangents are perpendicular to each other. And then they state there are multiple values of p for which this is the case. So if you move around this vertical line, there should be several times this situation. And then they calculate exactly the number of values of p for which these tangents are perpendicular. Oh, okay, we need to find the slopes of the tangents in A and B. So we need to evaluate the derivatives of both f and g in point x is p. And we know what the derivative is of f already. For g, it's just a cosine of x. They have to be perpendicular. Well, this comes around very often here. They're perpendicular if the product is equal to -1. So that's what we do. We multiply the expression of f prime with g prime. So you get a cosine to the power 4 minus cosine to the power 2 with some coefficients. And with these, again, this is a very common thing you have to do where you want to write certain equations in a quadratic form. And sometimes it's with different functions or even with square roots. But yeah, try to write it in a certain form that you know, a quadratic form, like done here. Just recognize that, hey, what if I say u is cosine square p, then I get a u squared here and a u here, and then it comes into a form I can actually solve. So what do I get? Get this equation here. With this, you just have to think a little bit how to factorize it, if possible, or either something that you see often as well is to complete the squares. But that's not necessary here. You will first try, okay, let's say I have u and plus something times 6u, because you need to have 6u squared. Well, that doesn't work. Then you try 2 and 3, and it turns out that you can find a suitable combination here. It's a little bit of trial and error. And again, you can just also, you can even try to find them by calculating it in your calculator, and then yeah, there are several ways to do it. So you find u is 1/2 or 1/3. And what does that mean? Well, u is 1/2 means that the cosine squared has to be 1/2, which means that the cosine of p is either plus or minus 1/2. And now, well, what are the solutions for each? Just draw this cosine, which I did poorly here. But so this is the cosine function with, say, p on the x-axis here, and let's see, p let me see. Yeah, so the domain of this function is from minus 1/2 pi to 3 pi over 2. So p also has to be in that interval. And then you can easily see that actually there are two solutions for plus and minus. So this gives a total of 4 solutions for p. And then do the same for the other option, that u is 1/3. And well, 1/3 will be a little bit lower than here, but you get also 4 solutions. So 4 plus 4 is 8. So the answer of question 3 is 8. And obviously you have to be familiar with solving this kind of equations. Question 4. We can rewrite f in this form. And this can, for example, be done by writing this for a suitable choice of t and u. So in this case, just follow what the hint that they're giving here. And from the equations given in the first or second page, this is given by 2 times the cosine of 2t times the sine of u. I would just also remember these formula actually. So then, so this here, sine x cosine 2x is the original function. So since you want to have a cosine of 2x and I have a cosine of t here, I just substitute for t 2x. And I want to get a sine x and therefore sine u here, so well, why don't we take u is x? And this equation is always true for, in particular, if I use these values. So just substitute them. T plus u is 3x, so I get sine 3x, and t minus u is 2x minus x is x. So I get this, and this is immediately already with the need to divide by 2, but this is already obvious enough that equation 1 is shown to be true. Then they say that these two functions have two common points, minus 1/2 pi 1 and 3 pi over 2 1. So that must be these 2 points here. So they kind of close in a certain area, and they call that phi. And they ask, calculate exactly the area of phi. So no graphic calculators. Okay, so what we need to do is the integral between the points given of t minus f. And that is just written here. Just substitute the functions, and I use that like second expression of f here. You strictly don't need to do it, but finding a primitive of this might be a little bit more tricky, but it won't matter. So get this integral, combine the sine of x, so you get like 3 terms, and for each you need to know how to calculate the derivative. And so for the sine it will be a minus cosine, and then here you need to again take into account the chain rule when you do the derivative. Again, as usual, double check by taking the derivative of each, and then you should find the original function. Then you just substitute it. These are kind of known angles, definitely something you need to know. Turns out all these cosines are 0, so you get just 4 pi. Okay. This is about water through a river. Again, as tradition, always kind of a word problem, where the math is actually not super difficult, but a lot of words. So they talk about a capacity of a river, which is something in the unit of cubic meter per second, and a time that the river can flood, or kind of a repeat time, and that is the time during which on average the river is overflowing once. So if t is 40 in years, it means that this river will overflow one time in 40 years on average. And there are two constants in this equation relating the capacity with the repeat time. And there they give an example of the river Rhine. They give the constants here. It must be dimensionless. And they also give the capacity. So what I want to know now for the Rhine, what is this repeat time, or the average time of one overflow of the river, and give your answer as a whole number. And in this case they say algebraically, so you can't use your calculator. Well, let's see. Okay, well, we know A and B, and so we have to calculate, we need to solve, because they give capital C and then the A and B, and they're asking for T. So that's a little bit messy. But, well, first you can rewrite this a little bit. Bring A to the left, divide by minus B. So then you get the log of this log is equal to C minus A divided by minus B. And let's just temporarily call that gamma. And then you can take the power of both sides, the power of E. And then you can work away one of these logarithms. And you do that twice, then you get T divided by T minus 1 is E to the power E to the power gamma. And again, these we all know. Gamma is a known value from what's given here. But let's call that beta temporarily, because we still need to express this T into this number. And then you find, multiply both sides by T minus 1. Just do some manipulation and you find T is this beta divided by beta minus 1. So what is our gamma here? Because in order to get beta I need gamma. I find minus 3.8 something. Put that into this fraction here. Then you get, just substitute it. Do on your calculator e to the power e of this number. Then you get 1.0226. Substitute it and then round it to a whole number, then you get 45 years. Then that's something otherwise we see a lot in the other exams. You have some equation, but you can derive something from that. In this case, they say that the derivative of c with respect to t is given here, and they ask to prove that. Okay, well, this is our function here. Well, no, it's not. You basically can split it and do some work first. Here, the derivative of a is trivial, it's 0. And then the derivative of the second term is just minus b times the derivative of this, like, double log. So we want to calculate this derivative, the double log, but inside we have this t minus t divided by t minus 1, which just temporarily call f here, because from the chain rule you need to know its derivative. So that's kind of the first thing I've done here, and use the rule for the derivative of a quotient of functions. So it's like the function in the denominator, which is t minus 1, times the derivative of the function in the numerator, and then minus the derivative of the function in the denominator. It's minus t times the derivative of the function in the numerator, and divided by the function in the denominator squared. And that's done here. So now I'm going to take the derivative here. It's using the chain rule. The derivative of log x is 1 over x. So I apply that. I go 1 over x, substitute for x I substitute this logarithm here in the parentheses, and then I need to follow the chain rule and do the derivative of that log that's here. So I keep this this constant in front and have to apply the chain rule again. I get then 1 over whatever is inside the parentheses, and then times the derivative of the function. So we apply twice the chain rule. And I already calculated that. I can substitute 1 over ft, which is t minus 1 divided by t. And then some terms drop. I get this expression here. And now I just need to multiply this by minus b, so I get minus b times that expression, but that's exactly what is given. So I've proven that. Then they ask, or they say that the longer this repeat time, the bigger the capacity is, which kind of makes sense. So that means that this graph should be increasing all the time. And then they ask to prove that. Well, that's not so difficult. We can just show that this derivative is always positive. If that's always positive, that means that c as function of t is always increasing. And b is given to be positive, 0 or positive, and t is greater than 1, so t times t minus 1 is positive. So we just need to show that this logarithm here is positive. And this logarithm is just the using some algebraic skills that you definitely need to know, is log t minus the log of t minus 1. And since the logarithm function is increasing for all x, we also know that the log t is greater than the log t minus 1. So we have proven that this is the case. And then there's another river, the Maas, in the Netherlands. And then if this is the capacity, then we have a 4 years repeat time. And if this is the capacity, then this is the repeat time. It's interesting why it has two capacities, because it's kind of the maximum. But okay, they want to know for which capacity the repeat time will be 100 years. I guess they have some means to increase the capacity. And then they ask us to calculate what capacity that is. So, and so to do that, we need to know A and B for this particular river. So we get two equations with two unknowns, just substituting these numbers here. This has to be, they didn't say exactly, fortunately. You can just plug it in your calculator, just keep sufficient decimals here. I kept 4 significant figures here. And you just use your normal skills to eliminate, for example, first A from these two, then you get B, substitute B in to find A, and plug these numbers in for 100 years. T is 100, and then you just calculate the capacity, and that is as a whole number is 3036 meters cubed per second. Circles. We have two half circles, C1 and C2. And for C1 there's an equation given, and with this called the center M1. And for C2 they just give the center and also the radius. And there is a point P on the positive y-axis. And they say they choose P such that the distance from P to circle C1 is twice that of the distance of P to C2. Okay. And calculate the y-coordinate of P. And two decimals. Again, meaning that you don't need to do it exactly or analytically. Okay, so, well, what's the distance from P to C1? Well, that's the distance from P to the center minus the radius of the circle or the semicircle. So that's given here. And the same for the distance from P to C2. So, well, we don't know the radius, or at least not directly, of circle C1, nor the center. So let's find out what it is. But they give the equation. So with this, as a common technique, algebraic skill, definitely need to know, I saw it several times, is complete the square. What you do is, you have here an x squared plus 12x. And now try to write that as a square of a term. And since you have a 12x, you put a 6 here, so that if you work this out, you get x times 6 plus 6 times x is 12x. But this x plus 6 squared is not exactly equal to x squared plus 12x, because you kind of overcount. You have a 6 squared extra, which you have to subtract. So a very common technique, and look it up if my explanation here was not that good. So x squared plus 12x we write like this, and we have our y squared, and it has to be equal to minus 32. So bring the 36 to the right, and there it is, an equation for a circle with center minus 60 and radius, the square root or whatever here, which is 2. And now we have everything we need here. Well, so P is on the y-axis, so x is 0, and we can just call it 0p. And now we need to demand that these distances are related like this. So the distance of P1 to M1, P1, we will in this expression we need to know the distance of P to M1, and for that we use Pythagoras, of course. So P to M1, it's the x coordinate squared, which is 6 squared, plus the y coordinate squared, which is our P. So you get this equation, and we do the same for M2, and you get this. And now we plug it in. So the square root of 36 plus p squared minus 2 is equal to this. And well, you can say bring everything to the left, and you can combine the constant terms here. Now in principle you can something like this you can do analytically by, how do you do that? You bring one square root to the right, or you isolate one square root here and take the square on both sides, and you have to do that twice. Actually, it's something like this. If you have the square root of x say plus the square root of y plus some constant is 0, you can just write square root of x is minus b minus the square root of y. You take the square, so you get x equals b squared plus 2b y plus y. And now you isolate this square root of y, so you write it as, well, I'm not going to do it here, but I think you get the point. You can isolate this and then do square again. I'm not sure if that's ever going to be needed. So, but then you get then you remove all these nasty square roots. But here, also because of time, you just plug it in your graphic calculator. Just define a function and find the 0 points of the function. And if you do that properly, you should get p equals to 7.02. Two moving points. We have two kind of parametric equations for a point 1 and point 2. For the speed v2, we have that v2 is the square root of 4, the square root of t squared plus 1. They already give that. Then they say that there's a certain time for which these 2 points have the equal speed, and calculate that. Well, this is the speed of a parametric function is calculated by taking the derivative of x over t squared plus the derivative of y squared. It's just basically like a two-dimensional generalization of is distance divided by time, so delta x divided by delta t. But since it's in 2 dimensions, it has components in both the y and x, so you basically apply Pythagoras to find the speed of the total. So it's like a Vx and a Vy. Okay. Let's do that then. What is dx dt of point 2? Well, it's given here t squared, the derivative is 2t plus 2. You need to take the square, and for x it's just 4t, so it's just a 4. Take the square root, and it has to be equal to v2, it's function of t. So set these equal, and square them, put all the like terms together, and again here it's very easy to make mistakes. It looks neat here, but I'm sure I made mistakes too. So best is to double check every step. Look at it again, since things can become very ugly if you make mistakes. So I end up with this quadratic equation, and again you try, there's a 3t squared here, so I just try 3t and a t and just try and error, find what will be the right numbers here. And if you cannot find them, again use the quadratic equation to find it. Or put it in your graphic calculator, and then the graphic calculator will say, oh, this is 0.3333 and 1, so then you know that it has to be 3t plus 1 times t minus 1. And since t has to be greater or equal to 0, then the only solution we can accept is t is equal to 1, which is the final answer. Then again we have these two curves, and then at a certain 2 times p1 and p2 come together. Yeah, you can see that. And if not, you can actually draw a line L through p1 and p2. Yeah, you know p1 and p2 at every time, so you can definitely draw a line through it. And this is done here. Then they say the slope of L is equal to minus 2 for every value of t. And that's interesting, so it doesn't depend on t. So prove that. Okay, well, what is the slope of L? It's the slope of a line going through P2 and P1, so it's simply delta y between the points and delta x between the points. And I call that SL. So, well, we know what we know our expressions here for P2 and P1. So substitute them. Factorize the common factor of the numerator is 2t, and the common factor in the denominator is t, and then you already just see terms dropping and you get minus 2, which is what they were asking. Next, question 13. On for which time is the x-coordinate of P3 equal to 3? Okay. Well, we need to take that line L and intersect it with the x-axis. We know the slope of L, namely minus 2. And so even if you didn't answer 12 correctly, or were not able to, you can just use that fact from question 12. And then secondly, what we know from this line, it has to go through either P1 or P2. And you can choose either one, because the slope is such that if it goes through P1, it will go through P2, and vice versa. So, what did I do here? I used point P1. I demand that 4t is equal to this minus 2 times the x coordinate plus b. and b is then equal to 2 squared plus 8t. So my line L is given here. So when does this intersect with y? Well, when does it intersect with the x-axis? Well, if y is equal to 0. So we need to set y here 0 and find out for which x that happens. So yeah, bring the t's here to the right, then you get t is equal to t squared plus 4t. So we found the let's see, this question. We found as a function of t what these coordinates of P3 are. And they're asking when is that equal to 3. So now we set this 3. So 3 is t squared plus 4t. And again, I think for the 5th time this exam we get a quadratic equation. And this one is, and play around a little bit, minus 3 as the factors. Factors minus 1, 3, 1, minus 3. And that actually doesn't work. So now you can use the quadratic equation, but completing the squares is actually, I think, a little bit more easy. And again, we have our t squared plus 4t, write it as a square. T squared plus 4t is t plus 2 squared. And then I get my t squared and 4t, but I get a number 4 too much, the 2 squared. So I need to subtract that. So get t squared minus 7 is 0. And then we find t is minus 2 plus or minus the square root of 7. And only the plus here will be between 0 and 2, which is what they're asking for. Actually, the minus one is negative. So so that is, let me see. Oh yeah, this is a t, not a b. So yeah, so this is our time at which the x coordinate of P3 is equal to 3. Okay. Question 14. There we have this function here, and they say that it has an inverse given here, and then prove that. Okay. Okay, so actually there is a long way and a short way, but they are both equivalent, so I just wanted to illustrate that. So what you can do is take the original function, and as you all should know, finding the inverse is just switching x and y. So finding the inverse of the function, I would try to solve, isolate y in this equation, try to express y into x, and find that it's equal to this expression here. So and how would you do that in this case? Actually, doing that is far from trivial. But since they already give it, we would just want to prove it by substituting. So in other words, I swap x and y here, and then I substitute for y this expression, and then I will show that this is true. So if this equation is true for this y here given, then I've shown that this is an inverse. And that's a little tricky, but doable. Let me just do the shorter one. And the shorter one is just looking at the inverse here, then do the same thing, flip x and y, so you get minus 2 times the cube root of x minus 1 becomes cube root of y minus 1, and is equal to x. So what I have to show is that that this is if I isolate y from this, I should get the original function. So basically I start with the inverse, and then take the inverse of the inverse, which is the original function. And well, so I get this, and just bringing the minus 2 to the right, I can just take the cube on both sides, and then I get y minus 1 is equal to x plus 2 to the power 3. And if you do that, you find the function f of x. Okay, and to do it, actually this is something that makes it a little bit shorter. Well, probably not much in this case, but definitely when I did it here, it's that a plus b to the power 3 is simply this expression here, with these kind of 3 and 3 here. So that reduces some terms when you're doing this kind of expansion. Okay, now they have a area phi enclosed by f, the y-axis and the x-axis. And you can rotate this around the y-axis. I think it's kind of you get a rotation body, omwentelingslichaam, and they ask the volume of that. Okay, this is actually the first time I saw that since going over 21 and 22 exams. But it is listed in this examen programma, and you basically need to integrate from 0 to y of the inverse function, and each will pick up like a pi, say, r squared. But I think this is an expression you can just write down without showing or proving it. And I'm pretty sure that will be okay. So yeah, you just need to be careful if the axis of rotation is the y-axis, you need to take the inverse function, right? If you rotate it around x, you can just take the function itself. But that's not what I'm asking. And the other thing is you need to know how far should the integration go. Well, that will go to where this the y value for which f is crossing the y-axis. So that is given by the function f at 0. And if I substitute 0 here, I get all zeros, I get a 9. So a here is 9. I have my inverse, so I just calculate, put down this integral. And this is a little bit tricky to do analytically, but just don't worry about it, just directly put it into your graphic calculator. And you find this 33.9. So yeah, if you don't know how to do that, you should definitely learn it. I've seen it more often. You should be able just to define, I think they call it y1. Give the boundaries of the integral and multiply by pi. Actually, you can have a primitive of this if you want to do it analytically. It is definitely possible. You have to also deal with some complex roots and stuff, because you get this is x minus 1 to the power 2 over 3. So the primitive will be 5 over 3. So at 0, for example, you get, yeah, that also has some complex roots. But yeah, that's beyond the scope here. This is just a plug-in kind of question, and the key here is two things. One is to know about these rotational bodies or rotation bodies, and to be able to do integrals numerically on your graphic calculator. Okay, last question. There is a point P for which the tangent is horizontal, so that will probably be somewhere here. And inverse, there's a point Q for which this tangent is vertical. Well, that makes sense. Just remember, the inverse is to have reflection of this in the y equals to x. So in this area, it will actually go down somewhere, go straight down. But find this, and this line intersects the y-axis in a point S, and calculate this y-coordinate. Okay, well, let's calculate this tangent of f. So the derivative of f is easy. I want to set it to 0. Again, that is quadratic equation number 6 probably in this exam. I find x equal to minus 2, and the function and the y, so that's the function at minus 2, is 1. So it is the point where this happens is minus to 1. Now I think you can immediately say already that the inverse must have the tangent, then the vertical tangent in point 1 minus 2. I'm not sure if that if you want to be really safe, you probably just do the derivative of this and yeah, prove that it goes to infinity when x approaches 1. Actually, it's actually not so difficult, so it's probably still best to do that. What is the derivative? There's always a lot of lag. It's just x minus 1 to the power minus 2 over 3. So times, of course, times, 1 over 3. This is 3 and then the cube root of x minus 1 squared. Well, yes, so this, if x here approaches 1, then this inverse will go to infinity, becomes arbitrarily large, so that's vertical. So now and then you should substitute x in the function, then it's minus 2. So yeah, it is this is the right point. Now we need to cross it, intersect with the y-axis, so find the line. We find the slope by the line by again delta y divided by delta x. So you get this is the y of q minus the y of p. This is the x of q minus the x of p. It's minus 3 divided by 3 is minus 1. So I have this expression of my line with slope minus 1. I demand p is on the line. I get 1 is 2 plus b. So I found my b is minus 1. And this is actually the of course the y-intercept, because when x is 0 then y is just this b, so y of s is minus 1. And that completes this exam.